I'm going to be recording the digestive system for AMP. So we're going to look at chapter 20, and we're going to start with the digestive system. The objectives for the digestive system, if you look on your paper as well, we're going to be doing the functions, the divisions, the differences in chemical and mechanical digestion, the segments of the digestive system, the different parts, the parts of the oral cavity, the parts of the pharynx, and their function in the digestive system, the esophagus, define the layers of the alimentary canal, like the mucus layer, muscle layers, talking about that, the anatomy of the stomach, its role in digestion, anatomy of the pancreas and its function, the gallbladder and the function of the gallbladder, and the structure and function of the liver. We're also going to be describing the anatomy of the small intestine, its many roles in digestion, the anatomy of the large intestine and its role, and then we're going to go a little bit through the process of we're not talking exactly about metabolism, but we're going to be talking about the digestive process, and then in chapter 21 we'll get a little bit more into the mechanisms of metabolism. So starting with chapter 20, we're talking about the digestive system, and it consists of the digestive tract, which is also called the alimentary canal, as well as the accessory organs. So the digestive tract is basically a tube that extends from the mouth to the anus, and the accessory organs are separate organs that aid digestion. So we have tissue layers of the digestive tract. The mucosa consists of 3 layers: an inner layer of epithelium, a layer of loose connective tissue, and a thin layer of smooth muscle. The submucosa is a thicker layer of connective tissue. It contains glands, blood vessels, lymphatic vessels, and nerves. And the muscularis consists of 2 layers of smooth muscle. The inner layer encircles the tract, whereas the outer layer runs longitudinally. This layer regularly contracts and relaxes to propel food through the digestive tract. The serosa, the outermost layer, covers the portion of the digestive tract within the peritoneal canal cavity. The outer covering of the esophagus and rectum is called the adventitia. So when people have problems with their digestive tract, they go see a gastroenterologist, and that the diagnosis and treatment of the diseases of the digestive tract is called gastroenterology. It's kind of interesting comment here in chapter 20. The bowel has been called the second brain. Not only does it contain more neurons than the spinal cord, it secretes neurotransmitters and hormones similar to those of the brain. So that's very interesting, isn't it? Now, something I want to bring your attention to, and I'll bring your attention to it in a minute. We'll go ahead and go with this, but I don't want to forget to go to page 390 and discuss mechanical and chemical digestion, because those are very important concepts. So we'll talk about the peritoneum. This is on page 391. And the layers of the visceral peritoneum are called mesenteries, and they suspend the digestive organs within the abdominal cavity while anchoring them loosely to the abdominal wall. Mesenteries contain blood vessels, nerves, lymphatic vessels, and lymph nodes that supply the digestive tract. And although this figure that you're looking at shows the intestines separated from each other, in actuality they're closely packed. The greater omentum is a portion of the mesentery extending from the greater curvature of the stomach and hanging down over the intestines like an apron. And it's showing it from the side here, as it has a side view. And then we're going to see in these other, as we go ahead, we're going to see the front view. It looks like an apron, and deposits of fat give it a lacy appearance. The mesocolon fixes the colon to the posterior abdominal wall. So here you can see in a frontal picture, here's the lesser omentum, and here is the greater omentum. So the lesser omentum extends from the lesser curve of the stomach to the liver. Because the peritoneal cavity contains empty space, it can fill with fluid from disease or trauma. The accumulation of fluid in the peritoneal cavity is called ascites, and we've talked about that a little bit, and we'll be talking about it more. So the layer of the digestive tract that contracts and relaxes to propel food forward is what? That's right, it's B, it's the muscularis. So let's pause here for a minute and turn back to page 390 and talk about digestion and discuss mechanical digestion versus chemical digestion. Digestion breaks down food both physically and chemically and transforms it into a substance that cells can use. Mechanical digestion and chemical digestion are two distinct phases. So it describes mechanical digestion as the first phase. It's physically breaking down food into smaller pieces, beginning with chewing and continuing with contractions and churning in the stomach and small intestine. Chemical digestion uses digestive enzymes, and that starts also in the mouth with salivary glands. Stomach, pancreas, and small intestines also secrete these enzymes to break down food into nutrients like glucose, amino acids, and fatty acids that cells can use. So it breaks it down into the very small particles that it can use. So once nutrients are released from food, they move into the epithelial cells lining the digestive tract before passing into the bloodstream for distribution throughout the body. Food that isn't digested or absorbed becomes waste, feces, and is eliminated from the body. So that is an important concept that I want to make sure that you understand is chemical and mechanical digestion. The mouth, moving to the mouth, is also called the oral or buccal cavity. The tongue is a skeletal muscle covered by a mucous membrane. A fold of the mucous membrane called the lingual frenulum anchors the tongue to the floor of the mouth. So in children, if this is short or it's very tight, it's called being tongue-tied. And in children, you'll sometimes see that little membrane snipped, so for free movement of the tongue to help in the baby to suck and also to help later on in talking. So the hard palate is formed by the portions of the maxilla and the palatine bones, and that separates the mouth from the nasal cavity. The soft palate, so if you're looking up here, you see the hard palate, and then you see the soft palate, and that's mostly skeletal muscle. It forms an arch between the mouth and the nasopharynx. And then this cone-shaped process called the uvula hangs downward from the soft palate. So if we look at the next thing, we'll be looking at salivary glands. So salivary glands secrete saliva, a clear fluid consisting mostly of water, but it has mucus in it, an enzyme that kills bacteria, antibacterial compounds, electrolytes, and 2 digestive enzymes. The parotid gland, right here, lies just underneath the skin anterior to the ear. Its duct drains saliva to an area near the second upper molar. The mumps virus causes swelling and inflammation of the parotid gland. So when they talk about measles, mumps, and rubella, mumps is the disease of where this is infected by a virus, and it's very painful disease that we have that there's now a vaccine for. So the submandibular gland empties into the mouth. So the submandibular gland here, and then the sublingual gland drains through multiple ducts onto the floor of the mouth. Enzymes contained in saliva begin the digestion process. Amylase breaks down starch, whereas lipase begins the digestion of fat. We have to chew our food very, very well begin the chemical digestive process. Often it's not beginning in the mouth because we don't chew well enough. Teeth. Digestion begins when food enters the mouth and is chewed, and this is called mastication. Chewing allows the food to become moistened with saliva. The adult mouth contains 32 permanent teeth designed to cut, tear, and grind food. So if you 32, that's including wisdom teeth and all your teeth, that's 32 as an adult. Chisel-like incisors have sharp edges for cutting food, and pointed canine teeth are designed to tear food. The premolars and molars have large flat surfaces for crushing or grinding. Excuse me. So let's look at the tooth. The crown is the portion of the tooth above the gum, and here, gingiva. Gingivitis is gum disease or gum inflammation or infection. The root and crown meet at the gum line, called the neck. The root is embedded in a socket in the jawbone, so this is the root. Hard tissue is called enamel, that covers the crown, and the bulk of the tooth consists of a firm yellowish tissue called dentin. The pulp cavity contains a mass of connective tissue, blood and lymphatic vessels, and nerves called pulp. Pulp also fills the root canals of each root. So a periodontal ligament lines the socket. Fibers from the ligament infiltrate both the root and the socket to anchor the tooth in place. A connective tissue called cementum covers the dentin in the root. Nerves and blood vessels enter the tooth through an opening at the end of the root canal. So which enzyme acts in the mouth to begin the breakdown of starch? That's right, it's A, amylase. So pharynx, the passage of food. After food has been broken down by the teeth and moistened by saliva, the tongue manipulates the bolus to the back of the oral cavity. At this point, the soft palate lifts, which closes off the nasopharynx, while the larynx rises, forcing the epiglottis over the entrance to the trachea, and food moves through the oropharynx and laryngopharynx on its way to the esophagus. So as we move down the alimentary tube, the next place we're going to go to is the esophagus. It is a food tube. It connects the pharynx to the stomach. A muscular sphincter called the lower esophageal sphincter, or LES, helps prevent the backflow of stomach acid into the esophagus. You may also have heard this sphincter called the cardiac sphincter, and that's because it is so close to the heart. So it's sometimes called the cardiac sphincter. Glands within the wall of the esophagus secrete mucus that helps lubricate the food bolus as it passes through. When a bolus enters the esophagus, it triggers wave-like muscular contractions, or peristalsis, that propel the food toward the stomach. So the stomach is a muscular sac whose primary function is to store food. It also prepares food for digestion, most of which occurs in the intestines, by contracting and churning to break food into small particles and to mix it with gastric juice. The process the stomach does that is a part of mechanical digestion. What results is a semi-fluid mixture called chyme. It's spelled C-H-Y-M-E, but it's pronounced chyme. Chyme leaves the stomach and enters the duodenum by passing through the pyloric sphincter. The normal curvature of the stomach creates two anatomical landmarks. You have the lesser curvature along the upper surface of the stomach and the greater curvature along the lower surface. The stomach is divided into these four regions, and you see this is named cardia. That's below the esophageal sphincter, and that has to do with the cardiac. Because it's also called the cardiac sphincter. The fundus, or the head or the top, the body, and the pylorus. And this would be the pyloric sphincter that leads into the duodenum, and the duodenum is part of the small intestines. The stomach contains the same layers as the rest of the digestive tract: mucosa, submucosa, muscularis, and serosa. However, the muscularis layer of the stomach has an extra layer of oblique muscle sandwiched between the layers of longitudinal and circular muscle. This extra layer allows the stomach to contract and churn vigorously as it processes food. When the stomach is empty, the mucosa and submucosa wrinkle into little folds called rugae. As the stomach fills with food, the rugae flatten and the stomach expands, allowing us to have Thanksgiving dinner. So the gastric pit is let's back up a little bit to the gastric mucosa. In the gastric mucosa, there are depressions called gastric pits. Several different glands called gastric glands open into the bottom of each gastric pit. These glands secrete the various components of gastric juice. Mucus cells secrete mucus, which protects the stomach lining and keeps the stomach from digesting itself. Parietal cells secrete hydrochloric acid and intrinsic factor. Intrinsic factor is necessary for the absorption of vitamin B12, and hydraulic acid helps kill microbes in swallowed food. Chief cells secrete digestive enzymes such as pepsinogen, and enteroendocrine cells secrete the hormone ghrelin, Ghrelin, which stimulates the hypothalamus to increase appetite, and gastrin, which influences digestive function. So what is the purpose of rugae? The purpose of rugae is C, to allow the stomach to expand. If you think about Thanksgiving dinner, you will remember that. So the formation and movement of chyme. Swallowing signals the stomach to relax so food can enter. Once the food enters, the following occurs. Contractions originate in the fundus and move toward the pyloric region. So the fundus is this top part here. So it starts up here and it moves toward the pyloric region. Starting out gently and growing progressively stronger, wave-like peristaltic contractions break down food and mix it with gastric juices to form chyme. Chyme is a liquidy substance. Chyme moves toward the pyloric sphincter, propelled by the contractions. Under the pressure of a contraction, about 30 milliliters of chyme squirts into the duodenum. And number 3, the stomach continues to churn and mix its contents as it gradually releases chyme into the duodenum. This continues until the stomach empties, which takes about 4 hours following a typical meal. So the next organ, the liver, is considered an accessory organ of digestion. It's the body's largest gland. It has 4 lobes. 2 of the lobes, the right and left lobes, are visible from an anterior or frontal view, and the right and left lobes are separated by the falciform ligament, which also serves to anchor the liver to the abdominal wall. So you see that right there. In the posterior view, you can see the caudate lobe near the inferior vena cava. So we'll find the inferior vena cava, here we go, and the caudate lobe, and the quadrate lobe here is near the gallbladder, and they're visible from behind. The portal vein carries oxygen-poor but nutrient-rich blood from the digestive organs and spleen to the liver. So the portal vein is here, and then the hepatic artery delivers oxygenated blood from the aorta to the liver. So we'll look at the hepatic lobule. The tiny 6-sided cylinders called hepatic lobules fill the interior of the liver. Sheets of hepatic cells called hepatocytes fan out from the center of the lobule. In between the sheets of cells are passageways filled with blood called sinusoids. Tiny canals called caniculi carry bile secreted by hepatocytes. So we're going to kind of go a little bit more into this hepatic lobule. Nutrient-rich blood from the stomach and intestines enters the lobule through small branches of the portal vein, for instance right here, and the blood filters through the sinusoids, allowing the cells to remove nutrients as well as hormones, toxins, and drugs. At the same time, the liver secretes substances such as clotting factors, albumin, angiotensinogen, and glucose into the blood for distribution throughout the body. Phagocytic cells, called Kupffer cells, you can see that one's hiding in here, and here's one up here, remove bacteria and also worn out blood cells and debris from the bloodstream. The central vein carries the processed blood out of the liver. Caniculi carry the bile secreted by hepatic cells and ultimately drain into the right and left hepatic ducts. So which liver structure filters blood to remove nutrients as well as toxins? That's B, the sinusoids. Let's take a look at the gallbladder. The gallbladder, which is attached to the underside of the liver, stores and concentrates bile. It's about 3 to 4 inches, 7 to 10 centimeters long, and holds 30 to 50 milliliters of bile. Bile leaves the liver by the right and left hepatic ducts. These two ducts converge to form the common hepatic duct, which goes on to become the common bile duct. Bile from the liver first fills the common bile duct before backing up into the gallbladder through the cystic duct. The bile duct merges with the duct of the pancreas to form the hepatopancreatic ampulla, or ampulla of Vater. The ampulla enters the duodenum at a raised area called the major duodenal papilla. The sphincter, called the hepatopancreatic sphincter, sphincter of Oddi, controls the flow of bile and pancreatic juice into the duodenum. So we'll look at the gallbladder has a role in fat metabolism because of bile. So let's take a look at the pancreas. The pancreas is both an endocrine and an exocrine gland. That means it secretes things through ducts and it secretes things directly into the bloodstream. Its endocrine function centers on pancreatic islets that secrete insulin and glucagon. Most of the pancreas consists of exocrine tissue. Each day, it secretes about 1.5 liters of pancreatic juice, essentially digestive enzymes and an alkaline fluid, into the small intestine. So that's a lot, 1.5 liters of pancreatic juice. The acinar cells secrete digestive enzymes in an inactive form. Once activated in the duodenum, the enzymes help break down lipids, proteins, and carbohydrates. Duct cells secrete sodium bicarbonate, which buffers the highly acidic chyme entering the duodenum from the stomach. It does such a good job that the gastric juice is very acidic, but pancreatic juice is very alkaline. Duct cells, so the sodium bicarbonate buffers that and makes it alkaline. The ducts converge on the main pancreatic duct, which joins the bile duct at the hepatopancreatic ampulla. Now, in the small intestines, this is where most chemical digestion and nutrient absorption occurs, is the small intestine. The duodenum is the first 10 inches, so this is green. It's represented in green. It begins at the pyloric valve and ends at as the intestine turns downward. It receives chyme from the stomach as well as pancreatic juice and bile. This is where stomach acid is neutralized and pancreatic enzymes begin chemical digestion. Most digestive processes occur here. That's the duodenum. The jejunum is the next 8 feet, 2.5 meters. Many large, closely spaced folds and millions of microscopic projections give the jejunum an enormous surface area, making it an ideal location for nutrient absorption. The ileum is the last 12 feet, or 3.6 meters. The wall of the ileum is thinner and has less blood. Clusters of lymphatic nodules called Peyer's patches are scattered throughout the ileum. So we're going to look here at intestinal contractions. Contractions in the small intestine help break down food particles, mix food with digestive juices, and bring digested food in contact with the intestinal mucosa to facilitate absorption. Contractions also propel food residue toward the large intestine. The two types of intestinal contractions are segmentation and peristalsis. Segmentation involves ring-like constrictions that occur at intervals along the small intestine. When the first contracted areas relax, new contractions occur in other locations. This back and forth movement breaks up food particles and kneads the contents of the intestines, mixing it with digestive juices. Peristalsis begins when most of the nutrients have been absorbed and undigested residue remains. Successive, wave-like ripples move the digested material along the gastrointestinal tract. So what's the purpose of the gallbladder? The purpose of the gallbladder is to store bile. That's the purpose of the gallbladder. So the intestinal lining contains multiple projections that increase its surface area and enhance the absorption of nutrients. The intestinal lining contains circular folds that slow the progress of chyme and increase its contact with the mucosa. On top of the circular folds are projections called villi. Take a look at the villi. The villi are covered by absorptive epithelial cells and mucus-secreting goblet cells. An arteriole, a venule, and a lymph vessel called a lacteole fill the core of each villus. Epithelial cells covering the villi have a brush border of ultrafine microvilli. These increase the absorptive area and produce digestive enzymes. Pores at the bases of the villi, called intestinal crypts, contain goblet cells that secrete mucus that helps the passage of food. They also serve as sites for rapid cellular growth, producing new cells to replace those shed from the villi. So let's take a look at chemical digestion and absorption. So we looked a little bit, went over that area on 390, but we're going to talk about what constitutes chemical digestion. And that's on page 404. So it uses digestive enzymes. It transforms food molecules into particles that can be absorbed, occurs mostly in the small intestine, and a process varies between nutrients, depends on the nutrient. So we're going to look at the carbohydrate digestion. And if you're looking in your book, you'll see that it goes through this step by step with pictures. It begins in the mouth with amylase, continues in the small intestine with pancreatic amylase, and finishes at the villi with sucrase, lactase, and maltase. So carbohydrates consist of sugars called saccharides, polysaccharides, disaccharides, and monosaccharides. Most foods contain polysaccharides, which must be broken into smaller particles. Salivary glands secrete the enzyme amylase, which hydrolyzes polysaccharides into disaccharides. The low pH of stomach and acid inactivates salivary amylase. By this point, about 50% of the starch has already been digested. In the small intestine, chyme mixes with pancreatic amylase and starch digestion resumes. The final steps occur at the level of the villi. The membranes of the epithelial cells covering the villi contain the enzymes sucrase, lactase, and maltase. As chyme slides against the brush border, the enzymes bind with the disaccharides. This is called contact digestion. This final step in the digestion process produces glucose, which is immediately absorbed. So that process is step by step on page 404 with the pictures. Protein digestion on page 405 begins in the stomach with pepsin, continues in the duodenum with trypsin, and chymotrypsin, finishes in the small intestine with peptidases. Before the body can absorb amino acids, now amino acids are the building blocks of proteins, but it has to break the peptide bonds, which it does with enzymes called proteases. Absent from saliva, the proteases work in the stomach and small intestine. In the stomach, the enzyme pepsin hydrolyzes the peptide bonds between certain amino acids. When chyme enters the duodenum, pepsin is inactivated. At that point, the pancreatic enzymes trypsin and chymotrypsin assume the task of breaking apart the peptide bonds. Finally, brush border enzymes called peptidases break the remaining chains into individual amino acids that are absorbed into the bloodstream. So let's take a look at fat digestion. It first requires emulsification. It continues with pancreatic lipase. Some fats are absorbed into the bloodstream of the villi. Other fats are changed into triglycerides and enter the lymphatic system. When a fat globule enters the duodenum, two substances in bile, lecithin and bile salts, break up the fat into small droplets. This is called emulsification. Once something is emulsified, it doesn't separate back out again. It's separated permanently from each other, like peanut butter. If you get natural peanut butter, the oil will rise to the top. But if an emulsification agent has been added to the peanut butter, the oil will not rise to the top and it won't separate. Once emulsified, pancreatic lipase, the main fat digesting enzyme, begins to digest the fat. Fats are broken down into a mixture of glycerol, short-chain fatty acids, long-chain fatty acids, and monoglycerides. Glycerol and short-chain fatty acids are absorbed into the bloodstream of the villi. Long-chain fatty acids and monoglycerides, which are too large to be absorbed by the capillaries, are absorbed into the walls of the villi. There, they are changed into triglycerides and eventually enter the lacteal of the villi. They travel through the lymphatic system and enter the bloodstream at the left subclavian vein. So here we have the large intestine. The main function of the large intestine is to absorb water. There's also an animation on the process of digestion that you need to look at. It'll go through the process step by step. So make sure you look at that animation. Once food has been processed and nutrients absorbed, the remaining residue enters the large intestine, and which absorbs large amounts of water before passing the resulting waste material, which we call feces, out of the body. The large intestine begins in a blind pouch called the cecum. So it's connected. The cecum here is connected to the ileum. Attached to the lower end of the cecum is the appendix. There it is. The appendix contains masses of lymphoid tissue and serves as a source for immune cells. At the point where the ileum meets the large intestine is the ileocecal valve, which helps ensure that material moves in a forward direction only. The ascending colon extends up toward the liver. So this is the ascending colon. The colon makes a sharp turn at the right colic or hepatic flexure. The transverse colon passes below the liver, stomach, and spleen. The colon turns sharply downward at the left colic, splenic flexure. That would be here. Left colic or splenic flexure takes a sharply downward. And then the sigmoid colon forms an S shape. So usually you see more of that S shape in pictures. And down to the rectum. Rectum means straight. The rectum is left 7 to 8 inches, 17 to 20 centimeters of intestine. The anal canal, which makes up the last inch, opens to the exterior through the anus. So this is the anal canal here. The anus contains two sphincters, an internal sphincter composed of involuntary smooth muscle and an external sphincter composed of voluntary skeletal muscle. So most nutrients are absorbed in the, where are most of them absorbed? B, small intestine. And what does the colon absorb? Water. That's right. The large intestine absorbs water. The small intestine absorbs nutrients, mostly. Okay, well, that's all for this part. And we're going to go on to chapter 21 and look at some mechanisms of metabolism. We're not going to talk too much about nutrition because you're either in that course or you've had that, but we're going to try to talk mostly about metabolism. Thank you.